round of applause for Siddhesh Kabe.
Okay. I was so confident when I entered in, and I was like, yeah, I'm going to do this. And I saw Keith, and I was like, no, I'm not doing this. Yeah, okay. So I'm going to talk about event-driven framework. So here was a scenario, right? So effectively what happened was we had a nice working system, right? And one fine day, it's just stopped working. Like, has that happened to you before? Like, no explanation, the system just stopped working. You are trying to find out what's wrong. And then you come to know someone down in the downstream system or upstream system, someone has suddenly upgraded something. They didn't bother telling you. They never bother telling you that they're doing something, and just everything is down, right? Keep that thought in mind. So, my name is Siddhesh Kabe. I'm a technical architect. That's what I go by. I'm just a guy who dabbles in Salesforce, dabbles in technology. I just love technology, different types. So I wrote a big agenda. I don't know whether I followed it because I didn't read the agenda after I wrote it. So I'm just going to go with the flow. I don't know what I did in the slides after this, but I did write the agenda thinking about it. I sent it to Amnon as well, but let's see what I did. So let's talk about event-driven framework, right? So I came across this 6 months ago while I was doing something else, and I've been just playing around with it. I actually liked it very much. I've been telling people to use it. Of course, not everyone listens to me, but if you like it, you should try to use it. I mean, event-driven framework is really cool, right? So, what is the event-driven software? Very simple. It's basically you send notifications from one end to another. I'm not talking about software. I'm not talking about systems. Just send notifications. We'll tell one. It relies on the publisher subscription model. So if you are familiar with REST framework or any other framework, you write an Apex trigger, you update something, a trigger runs, it updates something else. Everything has a dependency on each other. Instead of this, you just publish something. Hey, I've updated. Everything else who wants to subscribe to it will automatically get the information. They will do what they have to do. You don't have to bother about it. So it relies on publisher subscription model, and it has got one-way updates. Now this is very important here. It has got one-way updates. Just push the updates, and anyone wants that information can just collect it from you. We're going to dwell into details in this one. So that's the what, right? Very brief. Right. So how does this work, right? So we have a publisher, right? Now let's imagine this is Salesforce, okay? And you have some subscribers. Now Salesforce doesn't need to know who are the subscribers, or the subscriber doesn't need to know where the data is coming from, right? If you have a website, let's say, and the website wants to keep itself updated on the latest pricing, and you have a pricing team within your internal company, and they want to keep updating the pricing, they can do their job without worrying whether it will be displayed on the website or no, because at the point of time when the website wants it, they actually have a subscription. They can actually pick up the latest prices. So if someone queries on the website, they want to see the latest prices, they actually get it immediately, right? The best thing about this is easy scaling. How does that work? I can literally remove Salesforce out of the picture, put something else, and nothing happens to the downstream system. Nothing happens at all, right? It's a very simple model. You publish something, you subscribe something. We are sitting in BT offices right now. That's what BT does, right? You don't need to contact BT to connect to their Wi-Fi. Just open your Wi-Fi, find the BT, connect it. They don't need to know. All the network is already out there. The network is already out there. The Wi-Fi system is out there. Why can't our data flow like this, right? That's the why. So this is something I was trying to work. Let's see if this works. So imagine a very simple architecture diagram. Very simple. Don't push me on this. I just wrote this randomly, right? So you have a nice customer database right here. You need to capture the consent, any subscription that they have done separately so that everyone knows that no one contacts if they don't have the consent. You have a billing system where they can give money and whatnot. You have your website where you have a sales website where people can visit, they can see the registry, everything. Customer can register to your website. You can then send a newsletter. Very simple. A lot of companies use this model, right? They have these building blocks. Very simple model. Now, one fine day, the customer MDM team realizes, oh, hang on, but their MDM is not processing it as faster as it should, right? They're getting too many requests. They say, okay, what can we do about it? We have some budget. They say, let's upgrade our system, right? They just casually go ahead and upgrade it. Very casually, it's in their purview. They need to do something about it. The second they upgrade it, all these integrations that have gone through are broken. Now, imagine this, a consultancy came in, they built this entire system. The developers were actually very proud of it because it was a system that worked. It was a system that went live. People were using it. Now, suddenly, every inbound connection, every outbound connection has started breaking. It's not breaking. It might work, but you don't know about it. So you need to do an entire testing of the entire network, right? So what do? Oh, no, we need to hire some more people to fix all this, right? Now, but hey, good news. We have two things that are still working because they are not connected to your MDM, but that's not how it works. Because your MDM is broken, all these connections are broken. They could be, they couldn't. It's like a Schrodinger's cat at this point. They could be broken, they couldn't be broken. You don't know until you test it. Everyone knows what Schrodinger's cat is. You don't know until you test it. For testing it, you need to find someone. If it is broken, you need to find someone who can fix it. Now, these things don't have the data they require because you don't know whether this connection is working. So at this point of time, you're back to square one where you were 5 years ago when you built the entire system. All because this one system wanted an upgrade. So what happens if you actually move away from this model to a simple event-based architecture, right? You have a bus that manages all the connections. You have data flowing through the bus. So your sales, if someone subscribes to it, they send the data to the bus. That data then flows to the whoever requires that data. Now, if at this point of time, the customer MDM wants to upgrade your system, you actually need to worry about one connection, and that connection is to the bus. You just need to make sure that all the subscribers, that all the data that it is subscribed to, all the data that it is publishing is accurately publishing, because everything else is, remember, it's tested. The bus handles it, right? In short, this is what happens when you have a event-driven framework, right? You have someone who orchestrates all the data that goes through. You have someone, and all your systems are completely independent from each other. Extreme silence. Okay. Have we got any questions here? Nope. Okay. So let's dig in then. Then we'll go a bit deeper into this, right? So now this is where I'm going to focus on Salesforce, right? What options do we have within Salesforce to actually enable event-driven architecture? Now, if you look on the Salesforce website, if you look on the developers website, you also have some MuleSoft options that I've conveniently removed them from here because I just want to focus on Salesforce. Yeah. So we have so Salesforce actually provides us with few options that actually, and these options, I like these ones because you actually need very less code to actually implement this. So that was something that actually I liked it. That was something I liked when Salesforce is providing this, because everyone knows what outbound message is. Anyone here who doesn't know what outbound message is? Please. Okay, no one. And everyone knows what outbound message is, right? It's there since the beginning of time, or I don't know, Stone Age. I don't know how long it is. But I don't know how long it is going to be there. But it actually supports your sending your message. You can actually send a message through there. You have the platform events. If you're not played with platform events, I would highly recommend you just start looking at it. It's beautiful, right? You actually have platform events that actually handle your event-driven architecture within Salesforce. And Salesforce has recently provided us with your PubSub API, which is much faster than your REST API. It's almost faster. If you try to compare, it's not that much faster, but it's still a bit faster than your REST APIs. It's a bit faster, and it actually connects to your platform events very smoothly. These are some of the tools that are provided by Salesforce. And what are the options that we can actually use? What are some of the examples of where we can actually use this, right? So your multi-platform integrations, which is your standard integrations, which currently use REST, currently use SOAP, all those integrations can be upgraded to event-driven. You have the IoT integration. Now, this is a very important bit because nowadays a lot of IoT devices are coming in the market, right? You have new protocols that are in the market that are connecting all these devices together. So you have these real-time integrations, and you can literally you can connect these devices. You can have a motion sensor that can trigger things for a data capture just from the sake of it, right? So you can have these real-time IoT integrations. You can have mobile communications, your mobile notifications, SMS, GSM, IVR calls. All of these can be triggered using event-driven architecture. Right? Oh, and this is something I wanted to be very specific. It's not just about multi-platform architecture, but if you think about it, you can actually reimagine your triggers this way, right? And this actually came up from a very real scenario. You have your account trigger that updates your cases, your case trigger that updates opportunities. But hang on, these triggers are written 5 years apart. So all these things are dependent on each other, and within Salesforce, you're very close to hitting your governor limits as time goes by, right? So you can actually use the event-driven framework where one trigger then just publishes a platform event. Salesforce handles the event bus for you. That event is subscribed by another trigger, and they update the account for you. So you literally get a break in your transaction. You actually get a break in your governor limits, and this way you can actually improve your triggers. And this was something very cool, and this is something I was playing around with for a while. If you want to read more about this microservices framework, you can see that QR code. But with microservices, you can literally get rid of some of the governor limits problems that you have. Too many SQLs, too many queries, and these triggers are written like way older, right? So you get a break in your transactions. Okay, so I've been talking real-time a lot. It's not exactly real-time. It's near real-time. So there will always be a lag when a publisher publishes and a subscriber subscribes, but that lag is negligible, right? So if you have a human waiting for information, event-driven framework is probably not a good idea for you. If there's someone at a computer waiting for that information to come back in, event-driven framework probably is not a good idea. You need to think of something else. If you already have MuleSoft, there are a lot of, now this statement actually I copied from Salesforce side, because Salesforce actually recommends, if you already have a ESB in your network, they recommend you to use something else. Right? If you already have MuleSoft actually has got connectors that connect to Salesforce, and you can use them to connect to other systems. Within MuleSoft, right? So if you have something else, use something else. I don't know why they said it, but use something else. But if you already have it, and Salesforce recommends CDC data capture because everything else is now deprecated. They're still there, but your push topics and all are still there. Salesforce no longer supports them. It's a gray area, so I've just removed them. So, okay, I just spoke about it. Let me zoom in. So, any thoughts, anything at all?
You mentioned one of the advantages there is that you can effectively break your processing information out into multiple transactions. Presumably that also brings some challenges that you've got asynchronous in terms of those transactions.
Yes. Yep. Right. You're absolutely right. So the microservice framework, right? So when you break your if you use your event triggers, right, it is almost useful if you have a lot of after triggers. So if you look at your after triggers, you need not need that data immediately, right? So it won't be real time, but it's not like it's running after 3 hours. So it will just be, there'll be a few second gap in there. But all this data is of course asynchronous. So it will be something like if you have written at future method or asynchronous method, right? So a lot of these, what I observed is, and this came out from a very real problem where we had account triggers that was updating cases and case trigger that updated opportunity updated order, and then it again updated accounts. So this kind of chaining of events is usually very difficult to spot in the first go. So you actually have to test very carefully because these triggers are written by multiple teams across multiple timelines. It's very difficult for you to figure out where exactly the problem is. And if you have event services, right? If you write a case service or an opportunity service or an account service, you can actually get rid of these problems and you can scale very quickly. So that is an advantage that I find on this one.
Like if the cardinality of events to subscriber rate, it grows exponentially.
Mm-hmm.
How do I investigate if there is a problem occurs or if the system breaks? How do I know that which trigger has failed? How do I investigate?
Yeah. So that is, so I'm going to actually come to some of the frameworks, like some of the patterns that you can follow. There are some patterns that are recommended, right? If you, there are a few patterns that actually you can give a unique code to every event. which makes it almost like your REST API call, right? But if you need to have a guarantee of your delivery, then that is the pattern you need to follow. So it completely depends on your scenario, which scenario you're using. But there are, of course, as I said, this is just Event-driven is a framework. It's a new framework. So we have a lot of patterns. We have a lot of different options that we can try. There are some patterns, and I agree, there are some patterns where you might not get a guarantee that your message has actually received across the board, because remember, at the end of the day, this is fire and forget. So you need to make sure that all the nodes are actually behaving as is, right? Becomes a very big problem with your end-to-end testing. So if you want to actually do end-to-end testing, then you probably need to rethink what architecture or what pattern you're using in that case. Yeah. I'm going to address some of this after this.
Is there a recommended event bus architecture? Because I don't really, well, I understand it a lot better now thanks to you, but the architecture that we have, for example, we have, I assume Salesforce is the event bus for our record sharing events.
Yeah.
We do Apex sharing.
Mm-hmm.
And then we also publish out to an AWS mediation layer, so that's event bus number 2. Is it expected that you're going to have multiple event buses, or should it be like, no, we should go to one event bus?
Actually, very interesting question. I have a diagram that will come to that. But no, there is a very good chance that you might have multiple event buses depending on your complete architecture, right? Your AWS bus might be handling something else completely different. Ideally, in your architecture, you should always have one bus, right? But we don't live in an ideal world. Everyone goes agile, but we don't really go agile, right? We don't live in an ideal world. So of course, your requirement might be very specific if you need to have 2 event buses, right? You need to understand, if you're using 2 event buses, you of course have already made the assessment of where your source data is and which is your true source of information, who is handling your info. So you have done all that assessment. If you want to ask me which is your preferred event bus, I'll go with MuleSoft if there's Salesforce involved anywhere in the picture. Because MuleSoft actually allows you to, and this is something I came to know recently, MuleSoft actually allows you to connect to Salesforce using connectors. So you actually save a lot of time writing a code, testing a code, debugging code. So you actually have a connector, connects one system, right? And I tried recently, I can't tell you how, but I tried recently to connect it to Amazon Lambda as well. We didn't try all the systems, but that's what the data we were trying to flow. So you have connectors that are on the fly, like App Exchange packages, connect them and use them and start building stuff on it, right? So the question comes is, if you have all these connectors and you can actually leverage these to build something bigger, right? And not worry about where my data is flowing or where my data is stuck, because connectors are already tested for you, right? But I'll go with MuleSoft if you ask me, if there's Salesforce anywhere in the network. We actually did one pattern where Salesforce was the gateway to any data coming in and out of Salesforce. So if there's data coming in Salesforce, MuleSoft will, you have to send it to MuleSoft, and only MuleSoft will connect to Salesforce. But it's just something we did. Your requirement could be different as well. Yeah.
One question. Yeah. Did you see any limitations with CDC in Salesforce? Because when we did some review back in 2 years, probably 2 years back, for live streaming of data directly into GCP for reporting, absolute new reporting that we need, then we had this problem of some crucial objects not being available. Then you have this, calculated fields not being available, because some of the calculations might need to be recalculated on the target system.
Yep.
So all that particular problems existed back then.
I mean, a lot of these problems exist even now, right? So I mean, if you look at push topics, if you look at platform events, right? So you actually can only use your standard data sets. You can't use your formula fields. You can't use lookups. You can't even use lookups, right? That problem are still there because, of course, we are still growing and we are still building this stuff. But you have to remember, this is asynchronous data transfer, right? So if you're doing something, so you need to think of this as like an envelope, right? And it has to be uniform across the system. So it might not work for your use case, of course. And that is the limitation that we have to.
If you're publishing certain data to another system, it might be a reporting system as well. Yeah.
Yeah.
If you're publishing that data and if you're not publishing the calculated data, you are putting an extra burden on the target system to recalculate and things.
Yeah.
It's a 2-way. So if the formula changes on one system, you have to make
under the system, yeah. I think it has also something to do with a lot of how formulas are calculated in Salesforce. Salesforce never stores the data. Yeah. Okay. So yeah, I mean, because from the event framework, you can only send standard data. You can only send your literal values, right? Unfortunately, that's the limitation we have to bear with. Yeah. Yeah.
Yes, we were told about back then when we did the review of CDC that there will be a future release where it will support calculated fields and also some certain crucial objects like option line item, which doesn't exist today, even today. And all that, but we've never heard of anything like that.
No, so I think, yeah, so the good news is Salesforce is investing heavily in this technology as we go further, right? So if you look at a lot of these patterns and all these things, they've actually invested a lot of things. So maybe in the future you will get this will get much more sophisticated, right? If you think about where REST framework was 10 years ago when it actually started picking up, it was all soap before, and then REST came over, and now it's all become REST. REST has matured a lot, so we still have a time to go further, but yeah, so eventually maybe they will come with something, right? Yeah. So I actually found this. So this is actually a blog from Salesforce Architects blog, if you're not following it. Very good blog, and they gave us some of the patterns, and these are some of the patterns that I actually tested them, and so I just wanted to share some of these. This is one of the things that I wanted to talk to you. So we actually have like the publish subscribe unique copy, what problem that you have, where you actually in this pattern you have a unique identifier for each event that you fire, right? Now this actually goes against the concept of your event framework with your fire and forget, but sometimes, like you said, sometimes you have architecture frameworks where you need to know where the data is actually going. So this gives you the ultimate guarantee that your data will receive each subscriber, because everyone will get their unique identifier. The benefit for this is, of course, you can break in your workload. So if you have a huge data to process, so this actually will give you break in your workload. So your systems can process very quickly, right? And you can find faults, which is what you were saying, that how do you find faults, right? So this framework actually, this pattern actually allows you to to find faults within your system, right? Now it might not give you the benefits that you were expecting, but if this is what you're requiring, so this framework helps you. And this is the framework that will guarantee you deliver, like you know that all your subscribers have received your information, right? So fan out pattern, and this is my personal favorite. It's like a broadcast pattern, like your television, like your mobile phones. You just publish, okay? You just publish. Everyone will know what's happening. Whoever wants that data will come and collect it from you. You can send them the entire data packet. We have one more pattern, which is a bit different from this, where you just tell them that event has published, come and collect it from me. So fan out pattern, fast processing. You just publish. You don't worry about whether it reaches your subscribers. You don't know whether it reaches anywhere. So if they have a problem, they will investigate. Your subscribers will investigate. So as a publisher, you don't worry about it, right? This is easily scalable. Today you have 10 subscribers. You can add 100 in the future, because the publisher doesn't care about it. You just have to scale up your event bus. You have to scale up your you just have to scale up your entering architecture, but a publisher, you don't have to worry about it. One of the good and important use cases for this is MDM systems, which I found in my experience. So when you have a massive MDM system and a lot of subscribers, it can't just give latest information to all the systems. So it can just say, hey, I have a new information about the customer, take it. Whoever wants that information can just come and grab it from the MDM system. So this is actually a very useful pattern for MDM systems.
Sorry, only challenge for this pattern is it has to send the complete data set.
It has to send a complete data set. Correct.
Subscriber can either partially take it or fully.
Exactly. That's actually a good point. So with fan out pattern, you have to send the entire data set across the systems. And I'm going to come to one more pattern, which is a variant on this that will send partial data set. Yeah. So with the claim check pattern, now this is a variation on the fan out pattern, where in fan out pattern, if let's say I have a customer record, let's say 50 fields, I have to send the entire 50 field across the network. Now, some of these systems and some of the systems are very, very old. If you have a legacy system in your network somewhere, they won't be able to process all that information, right? In my experience, we actually had to send the customer. Avaya telephony system had to send us the customer information of the person who has called in via GSM network, which is 7 characters. That was all data they could store, because of course it's GSM network, nothing to do with the system. But your message. So what do you do at that point of time, right? They just send us a telephone number, and we then go and fetch the data using REST API from their database for the rest of the customer information, or any choices that customer has made via the IVR and everything. We can just collect it from there. So your messages very small. So you can send it across legacy system, you can send it across mobile networks, you can send it across notification SMSs, you can send it across anything you want, right? So that's why I mentioned the point number 2, where you have very constrained system like a telephony system. This is very useful pattern for you. The benefit of this is, of course, your message is very small, so it goes across system. The drawback of this is you still have to rely on the other network calls to come and collect the data for you, right? Because you're only sending the identifiers for them.
Sorry, I have one question if you don't mind. That record identifier has to be unique across the system to come back and collect, right?
Not necessary. So record identifier is unique for your system. So they will get the identifier, come and query the data and get it back.
So I have a customer ID which is tied to an account ID. So where does the translation should happen to go and collect?
So basically, imagine this scenario. So if you have a customer ID in your MDM system, right? All you have to do is this customer ID has been updated, right? So if there's an account ID on a different system, for example, they can use the customer ID to query the rest of the data. So it's your ID that you're sending them that this data has been updated. So you don't have to worry about others' IDs, what they have.
I have a question also. For the fire and forget pattern, you said mobile notifications was a good use case for that. How do you work within event limitations for those mobile notifications? So say you need to send out a notification to 1 million customers or 60 million people, like the government failed to do the other week. How do you scale that and fit it within your government limits?
So here's the interesting part, right? So you don't have to fit it within your governance limits. You just have to publish the record. At that point of time, you don't rely on Salesforce Event Bus. No, definitely don't rely on Salesforce Event Bus. You need to get an external ESB that can manage that scale up, right? But also, I think mobile network is, so if you want to actually do a public broadcast, I think there's a complete different framework for that. Because I think that I could be wrong, but the data actually goes to multiple data centers and multiple events are published across the data center. But for your purpose, you just have to publish once and the entire network will get the data.
So you're publishing the actual notification to the subscribers and pushing that.
No. You just send it to the event bus in between. I was actually reading what the government was trying to do, and that's how I know, because they're actually trying to fan out across the network, and then all these networks are publishing across the network. This is what I read. I'm not sure, but I think reaching public broadcast is a complete different. Public broadcast is a complete different thing.
It's probably a bad example.
Yeah.
But it was a bad example of
Yeah, but don't rely on Salesforce event bus if you want to do across the board, right? You need to have a proper event bus that will actually do that for you. Okay, so queue processing, right? Now, queue processing is something that has actually caused more problems than it solved, but still, it is still an effective way of dealing with effective pattern, right? So what happens when queue processing is you effectively have a staging area in between where all your messages that you published are queued up, and then the messages then go through. We had a big problem with this when you have a dependency, like if you have an account data and opportunity data, both are sitting on queue, you don't know which one comes first. So you have to solve for those kind of race conditions that come with the queuing pattern. But queuing pattern are very useful if you have devices that are on the field, if you have mobile devices, if you have people who are offline for a time, and when they come online, they'll receive the data, right? So these kind of systems are very useful. If you have a huge data set, and your downstream system is not capable of handling it, like what we had, because we were collecting data from a data lake to Salesforce, and data lake is huge. They can process a lot of things. Salesforce cannot. So then we start buffering the data and then start pushing it in chunks, right? You have other problems with it. You have to retry and everything. This presentation was going too out of hand, so I stopped at retry. But event framework in Salesforce actually also comes with retry mechanism. So you can retry every message within 24 hours 4 times. You can retry the messages. So you can also retry any within the framework. The better use for this with queuing process, and this is something someone told me, was there are many systems that require regulatory conditions where you have to store the data for a period of time. Right, with fire and forget, you actually forget the data, so you don't capture. Once the subscriber received the data, you don't know what event is fired. So buffering actually helps you. You can retain that data for a period of time, at least until your regulatory guidelines allow you, and then you can move on from there. So this actually creates like a small buffer zone between your publishers and subscribers. Okay. There are a few more patterns. I just collected 4. There are a few more patterns. So I'd highly recommend this blog. This is on the Salesforce Architects blog. That talks about more patterns, and they have some more diagrams and all. Any questions here? Anything? Any thoughts?
How does the replay plays into these patterns, the performance implication on replay?
Yes. So with the replay, right? What you can do is, so if you have an event coming in, right, and for some reason it failed, and most of the time it failed when it didn't find a parent. It didn't find a parent, or if they tried to update a record that was already getting updated because it was buffering and all, it was a race condition. So at that point of time, you can add a replay within an hour or so, and it will again publish a platform. It will re-trigger the same published event within Salesforce to then try to do the task that you're doing. So if you have triggers on there, the triggers will run again at that point of time. So you have to be careful on how much volume you're doing, because the replay is actually going to double that volume. So if you have 400 events coming in Salesforce, you'll get 800 in a day if all of them fail. That's your worst case scenario that you have to handle.
And how do we handle the idle potency if there are unique transactions? Like I'm doing things, how do I handle the idle potency when I'm doing the...
Yeah, so that is the thing. So you actually need to have there are patterns that you can follow to handle that, right? But one of the important things you can do is you can have a state. So the subscriber needs to maintain a state of something that has come in, and this is where I found a limitation of platform events where you can't have a lookup, because then you could just query and check it. But no, you need to have a unique identifier, so you can identify at the very end stage. So what the problem is, like if you have a unique payment record or something, right, and if the payment has already come in, right, because it's a race condition, then you still have another one coming in, but it's the previous transaction. You don't want that. So you can actually have a state. You can have a unique identifier, and then you can query that and then reject the incoming message. There are different ways. So there are multiple patterns that you can use to handle those, and a lot of these are online, so you can actually check. And I found AWS blogs actually have a lot of event patterns. I think they have a lot of these issues coming in. So I didn't have a link for that, but yeah. Okay. So, any questions? Any final thoughts?
Like when you are comparing this to a large scale projects, you might what I feel like you might end up using multiple patterns in one go because of different classifications and data requirements in series. It might not be just one single pattern. Like in technical aspects, if you have Apex framework pattern, you might go with one pattern for the whole organization. But here you might go with multiple patterns in one.
So this is where your enterprise level architecture comes in, right? If you have an enterprise level project, you need to think it from the bottom, from top to bottom, right? So you need to have these patterns and frameworks established early on. You can't just have one pattern for one system and another pattern for another one. Now there could be cases, and those are some of the limitations of cloud systems where they come in this big network where you could have 2 event buses, but that is only for the downstream, like only for systems that are not compatible with your event bus. Ideal cases, you should have a common event bus, and a lot of people in Salesforce don't like this, but Salesforce is just one of the consumer within the whole network and not the center of the whole network, right? But that's we like to think of it. But no. But if you have an enterprise system, if you have a large scale system, you need to think about the bigger picture, not just Salesforce. Yeah, I hope that's yeah. So in conclusion, just 3 points. Yeah. Eventful patterns are easy to scale for large organizations. They are not real time, but near real time. I've written real time a lot in this. That's why I had to light this line at the end, just to be clear. Safe harbor, right? Event-driven framework are better used to connect multiple systems together. I say this better. I found them much better from the REST framework. Now that doesn't mean that you have to go with this all the time. There could be cases where you have to go with your REST framework, which are tightly coupled, but with the performance and all, I found them a bit better than the REST framework. So it's a subjective word. Thank you. Yeah, that's it. Yeah, that's my blog. If you want to connect, my LinkedIn, Twitter, everything is over there.